In this video, I'll be working through all the questions from the summer 2025 Cambridge A-Level Maths exam, paper 3-2. It's going to be a long video. I do not want to just give you the solutions. I'm trying to teach you how to do each question, and that takes time. Remember, we're not in the classroom, we are on YouTube, so take advantage of their tools. Use the chapters in the timeline to jump to the question you're interested in, and certainly pause and rewatch more difficult parts of a question. You can also change the speed you even watch the video at. Okay, let's jump into question 1. In question 1, we're given this equation here with exponentials in it, and we're simply asked to solve it. That means get x on its own. You probably want to try and get ex on its own first. That's not going to work out in this case. Basically, you want to rearrange this until you see a method to solve it. Feel free to play around with it, do different paths to the final answer. The first thing I would suggest doing is this bottom row. Always get rid of these bottom rows. It makes it just much easier to deal with. Dividing is horrible. Okay, so we'll multiply everything by ex minus 3, this whole term on the bottom. The left side, it'll just disappear, and it will reappear as a multiply on the right side, ex minus 3. Okay, next thing, I guess we could multiply this out, 4ex minus 12. So we have ex here, and ex here, and e minus x. Tantalizingly close looking to each other, but they can't really interact all that easily. But this one and this one can. So let's move everyone over the left-hand side. We'll get this ex minus 4 ex's. So we'll have minus 3 ex. We'll have 2 e to the minus x. And while we're at it, because I know what's about to happen, I'll move this minus 12 over. It's okay if you hadn't noticed that yet, because this doesn't really look like anything useful yet, although it comes up in the exam enough that you probably want to start recognizing what's happening here. Let me, instead of e to the power of x, let me rewrite that as, e to the minus x, let me rewrite that as divide by e to the x, because that's what it is. That's what the power of a minus is. Now, maybe now you're starting to see what will happen, but maybe not. Once again, we have one of these divides we don't like. Let's multiply everyone by e to the x. I'll do it up here. We'll have minus 3 e to the x, e to the 2x. E to the x times e to the x is e to the 2x. Plus, that'll become a 2, plus 12 e to the x equals 0. Are we starting to recognize what this is yet? Let me change this and I'll move these around. Instead of writing e to the 2x, you could have also just write e to the x squared. It was e to the x times e to the x squared. We could have plus 12 e to the x. Let me put a bracket around that. Don't have to, but maybe that'll help. Plus 2 equals 0. This is a quadratic. Something squared, something, no somethings equals 0. This is a quadratic expression. Let me multiply everyone by a minus as well. And if you'd rather, I won't do it for the rest of this question, but some students do. Instead of e to the x, maybe it might be more useful to write y squared, or k, or p, or any letter you want really. Plus 12, this become I'm multiplying everyone by minus, aren't I? 12 times y minus 2 equals 0. Now it looks like a quadratic, hopefully. I'll just stay using the e to the x instead of the y. But it's if you have trouble with that, if you just don't like the way it looks, it feels too hard to you, definitely replace it with the y. You could try factorize this. 2 numbers multiplied to get 3, it's only 3 and 1. 2 numbers multiplied to get 2, it's only 2 and 1. We can't get them to work together to get us a 12. So factorization's out. We're going to have to use the minus b formula, or complete by square if you'd rather. But I'll use the minus b formula. We get e to the x is equal to minus b. That's the term in front of this one, so that's 12. Plus or minus the square root of b squared. Minus 12 squared is 144. Minus 4 times a times c. That's 2 minuses, so we get a plus. 4 times 3 is 12, times another 2 is 24, and that's divided by 2 times 3. That's 6. Clean this up, we'd get 12 plus or minus the square root of, let's see, 68. 168 divided by 6. We can clean that up more. Everyone can be, well, it looks like everyone can be divided by 2. 12 can, 6 can. We'd have to check if this can be divided by 4 because the square root. And it can. I have it here somewhere. Yeah, it goes in 42. So 2 goes into 12. 6 times 4 goes into this 42 times. So square root 42 over 3. That's e to the x. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Remember though, we're not looking for e to the x, we're looking for x. So get the natural log of both sides. Let me do that over here. The natural log of e to the x is just x. And that'll equal the natural log of 6 plus or minus the square root of 42 over 3. That looks like we've got 2 answers. You can put that into a calculator there. It looks like we have 2 answers. But there's a couple of problems with that. First of all, if you put it into a calculator, you'd get an error for one of those answers. And the other problem is the question said give your answer. It didn't ask for answers, give your answer. So what's the problem here? You can see it either here or here. Natural logs cannot work with a minus number. And the exponentials will never equal a minus number. So this minus here, 6 take away square root of 42 is 6 point something because 36, square root of 36 is 6. So this is bigger than 6. So 6 minus something bigger than 6, that would be a minus. So we have to take out the minus 1. So your final answer would have to be x is equal natural log 6 plus square root of 42 over 3. They wanted that in decimal places. So if we put that into a calculator, we'd get 1.426. That's rounded off to 3 decimal places. Okay, you would lose a mark if you left 2 answers, but that was quite nice of them to get you to put it into a calculator to get the decimal place number, because you should have found an error on one of them. If they had left you leaving your answer looking like this, you would have lost a mark for having 2 of them without discounting one. Okay, that's it for question 1. If you have any follow-up questions or you'd see any error I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day. In question 2, we're given this expression here and we're asked to write it in ascending powers of x. So this is a quite common question to be given. So you should be thinking binomial expansion. We should be thinking expanding this term here. Usually it's something like to the power of 7 or 8. But every now and then they throw in a harder question where it's a minus number or a factor, a fraction, like it is here. We use a slightly different formula. We have to, the term has to have a 1, and this number has to be less than, the absolute value of this number has to be less than 1. So there's a few restrictions, but they still just give us a formula for expanding a term just like this in our formula tables. So we can go ahead and just start expanding it out. Let me write this guy. We'll deal with this one later. Expanding this out, I'll open a nice big bracket. The formula just tells us that, before I do that, let me write this one more time. 6 minus x multiplied by something to the power of 3 over 2. Something that trips up a lot of students is the formula they give us has x in it, but it's not the same x as we're looking at here. This is actually 1 plus minus 2x. The x they give you in the formula is whatever's in this bracket. It's 1 plus whatever they've given us. So the formula they do give us is 1 plus n times x. That n is minus 3 over 2. that x is minus 2x. The formula continues and says plus n, or sorry, instead of n we're putting in minus 3 over 2 multiplied by n minus 1. 3 over 2 take away 1 is minus 5 over 2 divided by 2 factorial. That's 2 times 1, which is 2, multiplied by x squared. Well, that's minus 2x all squared. And this continues on, plus dot dot dot, continues on like that. I don't need to continue on because they asked us to just get terms up to x squared. And so I would never need an x cubed term. Remember, we still have to multiply by this guy. There's nothing here. Maybe if 1 over x was here, we would need x cubed. But there's nothing x cubed can multiply. X cubed by 6 will still have an x cubed in it. X cubed by x will have an x to the power 4. I definitely don't need that. So we have more than we need here to multiply all this out together. First, let me clean up the second bracket. Let's see, 1 is fine. Minus by minus is a plus. The 2's cancel. We get 3x. Let's see, minus by a minus, by another minus, by another minus. That's 4 minuses. So again, we have a plus. There's 2 2's in here. One of them can cancel with this, and one of them can cancel with one of these. So we're just left with one of these 2's and 3 times 5. So that's 15 over 2. And we have an x squared and plus dot dot dot. That continues on. Yeah, if you forget the dot dot dot, that's fine. I just like always putting it in. Okay, let's multiply these two brackets together and see what we get. 6 times 1 is 6. 6 times 3x is 18. X 6 times 15 over 2. 2 divides into 6 3 times. So 3 times 15 is 45 x squared. Okay, minus x by 1 is minus x. Minus x by 3x is minus 3x squared. Now, you're not really going to lose any marks once you get rid of it later, but we don't have to multiply x by this term because it's an x cubed. We're not interested in x cubed. They told us to ignore anything more than x squared. Only include up to x squared. So I don't really care what's left. So I was able to save a little bit of work there. Last thing, just clean this up. We have 6. All the x's. We have 18 minus a 1. So that's 17x. We have 45x squares. Take away 3. That's 42x squares. And that continues on. We don't care. That's all the terms up to and including x squared. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. They've added in an extra 1 mark question in part B. I touched on the answer to it earlier. State the set of values of x for which the expansion is valid. Well, in our formula tables, they tell us this only works when the term that's here, or let me write it as the minus 2x, the term that's there, the absolute value of that is less than 1. Actually, you know what? Let me clean off the board and we'll do this as its own little question. Yeah, I think it's worth doing this on its own. You're only getting 1 mark for it, but I think it's a hard enough question for 2 marks, to be honest. How I would answer this is I'd draw a picture. I'd draw a picture of minus 2x on an xy axis. That's 2x goes up like this, minus 2x goes down like that. It would look something like this, minus 2x. The absolute value though, let me put a dot 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 down on the bottom one here. That means this doesn't happen, it just bounces back up. So the drawing of the absolute value, let me put that in there, looks like this, V-shaped. So when is that less than 1? We'll there's 1 drawn in. So it's between these 2 points. Whatever this point is and this point is. And you can find that just by taking either one of them. Minus 2x equals 1. When does that intercept? It'll be the same answer over there. That happens at x equals minus a half. So that's minus a half. Do the same thing with plus 2x, that you'll get a half over here. Either way, the answer is when x is between these two numbers. Is it greater than or equal to? Let me look. No, greater than. Between these two numbers, minus a half and a half. Another way to think of that is just from here, you could say minus 2x is less than 1 or 2x is less than 1. This one just says x is less than a half, and well, let me write this one again here, minus 2x less than 1. This one says x is greater than, because we're changing signs of both sides, so we have to change the greater than minus a half. That's what I got here. That's another way to do that. Yeah, they want to see this, they want to see that, or this. I checked the marking scheme and there's something that's not there that I think maybe should be there. Maybe I'm wrong. I rubbed out the original question, but it had, let me check here, had 1 minus 2x to the power of minus 3 over 2. When is the expression valid? I'm always worried about dividing by 0. So this is dividing. A minus means it's dividing. This is the same as 1 over 1 minus 2x to the power of 3 over 2. So I'd always be worried, when is this 0? 1 minus 2x, when is that equal 0? Well, that happens when 2x equals 1, so x equals a half. So not only is it not valid when it's less than a half, I don't think it's valid when it equals a half either, because of dividing by 0. So I'd put that in for full marks. I don't think the examiner would take a mark off there, or maybe I'm wrong as well. That's very possible. Okay, that's it for question 2. If you have any follow-up questions, let me know if I'm right or wrong about that, or if you see any mistakes I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 3, we're dealing with representing inequalities of complex numbers. I think this topic, to learn it properly, is probably one of the hardest topics in the A-level course. But the good news is you don't actually have to learn. We don't go into the harder parts. What we're about to do here is pretty much all you need to know about this section to do the A-level. If you go on to do further, I'm not sure if it's in further maths, or if you go on further in maths, like into college, it will get a lot harder. But for now, we mostly just have to remember what I'm going to go through. I'll try and explain a little extra instead of just doing the answer. I'll take this into 2 parts, even though we want one drawing at the end. I'll do 2 different drawings and then combine them. Modulus, the modulus of z. This is a number we don't know yet. Take away another number. What does that look like when it's less than or equal to 2? First thing I want to do is I want to change this to minus and put a bracket in, 3i. Because you have to be careful, we always want a minus here. So even if this was plus, we need to change it to minus something in that case. It didn't matter too much here, but I just wanted to point it out because if the question was slightly different, it would become important. What we have here, the modulus, what it actually tells us is the distance between 2 points. The distance between z and 3i is less than or equal to 2. Let me draw that out. Let's put 3i in first. 3i is 1, 2, 3 is up here. They're saying, I don't know where z is, but the distance from z to 3i is less than 2. So here's 2 away. So it's somewhere inside that. But here's 2 away, here's 2 away, here's 2 away. 2 away turns into a circle. They're saying that z is somewhere in that circle. I probably should have a dotted circle because, oh no, it's less than or equal to. So sorry, it's not a dotted circle. Okay, so it's on that circle or somewhere in it. So I'd shade this whole circle in. That would what this one looks like. They didn't ask for each of them shaded, but I'll do it. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. onto the argument. We actually have two things here. The argument is something similar. I need to change this to z minus something. So it's not minus 1 minus 2i I'm looking at. I'm looking at 1 plus 2i. It's minus of that. You need to be careful of that. Let's draw that on in its own diagram. We go to this. What this one is saying is if we draw a line between this point and z, it will have whatever angle, or in this case it'll be, the angle will be less than this or greater than that. So if I draw 1 plus 2i, I go 1, I go up to, put it here. They're saying, well, if this was equal 90 degrees, well, first thing we do is actually we draw a whole new baseline, because this is where our angle goes. It always starts here and goes that way. So let's just start with this one over here. They're saying the angle it makes with z is greater than pi over 4. So we start here, that's pi over 2. Pi over 4 is a 45 degree line. So a solid line in this case. So what this says is it's greater than that. It's somewhere between here and here. Now that's not the only information they gave us. They also told us it's less than or equal to 3 over 4 pi. 3 over 4 pi is here, going up like that. So to be in between these, it's this whole world here. And this goes on forever up there. The final thing we have to do is just combine these. You didn't have to draw them separately. I was just doing that to help teach you. You probably would have drawn this both on one drawing. Let me put them both on one new drawing, and I'll be a little careful, like 1, 2, 3. I'll try and draw it as neatly as I can. 1, 2, 3, 4, 5, something like that. The first one was the circle. It was at this point, and it went between, I guess I need another 1, 2 out here. It went between all of these. So, bad drawing of a circle, but still. I need to be careful because this guy is in fact in there. 1, 2. It is inside that, and it came up at a right angle, a 45 degree angle. So that means it actually went right through this point. It's interesting. And it also went, right through this point here. That would have been at the side of it. So when did both these shades agree? It's this shape in here is the answer to that question. Okay, that's it. There's a lot of marks for that, for just drawing two pictures. You could answer this question so quickly. You just need to remember what all this means. It's probably, I said it's the hardest thing in the exam, but it's probably the easiest thing to get marks for, because it's the same thing comes up. If you just study 8 of these questions, you're going to probably see something very similar and be able to write the answer in just a minute or two. Okay, if you have any follow-up questions or see any mistakes I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 4, we're given this trigonometric equation and asked to solve it. First thing I do not like cotan. This is a COT here, cotan. I never used it myself all the way through college. The first time I seen this was when I taught in an international school. I taught the A level. It's not done in the Irish exams. We don't use cotan. I never did it in any of my college courses. I don't like it. I get rid of it straight away. How do we get rid of it? Cotan is just 1 divided by tan. That's what I used all the time. So we can rewrite this as 3 over tan x. We can rewrite this one as minus 4 over tan 2x equals 3. Why complicate it by having a new name for something that's just 1 divided by tan x? We know how to deal with tan x, tan, sine, cosine. That's enough for me. I hope that you can do this by keeping it in cotan if you want. I don't. I like to change it. Same with cosine and cosec. I change it all back to their original ones. Okay, what do you do next? Next thing I would do is I look at this one and go 2x. Don't like 2x. I have a formula to fix 2x. It's in our formula tables. We can, instead of writing 2x, we can write, well, let me write the rest first. 3 tan x again minus 4. Instead of 2x, let me put it in as a whole bracket. what we got here, we have 2 tan x over 1 minus tan squared x. We can just replace it like that. And now we have an equation with everything's the same in it. It's just tan x's everywhere. If we can combine these, move these around, combine them, hopefully we can solve that. So let's try and do that. First of all, we're dividing by a fraction. So we can flip that upside down. So I can rewrite all of this as, let's say, 3 tan x minus 4, well, yeah, we'll write it in like this, 4 multiplied by 1 minus tan squared x over 2, I could have divided that in at least, equals 3. Alright, the 2 goes into the 4 2 times. We have the same bottom row here. We can combine this, or we can just multiply both sides by tan x. And that's what I'll do. Multiply that by tan x, we just get 3. Multiply this by tan x, the bottom row disappears. And I'll take the opportunity to multiply it in. 2 times 1 is 2, minus, minus 2 times 1 is minus 2. Minus 2 times minus tan becomes plus 2 tan squared x equals, this guy also gets multiplied by tan, so it's 3 tan x. Hopefully we're recognizing what this is. It's a quadratic. We have an x squared term. We have or something squared, I should say, not x squared, something squared. That's another something and a term without it. Let's just rearrange this so it looks more normal. We'll have 2 tan x squared first. That's the squared part first. Then we'll take this over and we'll have minus 3 tan x. And let's see, 3 minus 2 is 1, so we just get plus 1. All that equals 0. If you don't like having tan x here, you can change this for just y squared and y. A lot of students like to do that. But this is just a quadratic that can be factorized. It's not too bad. How do you make 2 tan squared? Well, that would have to be tan x multiplied by 2 tan x. How do you make a 1? Well, that'd have to be 1 by 1, if it's easy to factorize, that is. And this does work out. Tan by 1 and 2 tan by 1, it gets you 3 tans. That's what we want. Oh, hang on, it's minus 3 tans. So we need minus 1 and a minus 1. But that still gets us to a plus 1. So here's our answers. Tan x equals 1, or tan x equals 1/2. You don't have to, you can put these in your calculator and just trust it. But at this point, I do like to draw a little picture. What does tan look like? It looks like this, and then it comes down like that. Well, it continues on like this, like that. And this point here is 180. So their answer, they wanted, sorry, it continues on this side as well. Let me draw it like this, something like that. And the answer they're looking for is between 0 and 180. It's in this world, 0 and 180. So their answers of 1.5 are here, here's an answer, and here's another answer. So nothing complicated. The calculator, just putting these in the calculator will solve this fine. 1 works out, 1 is 45 degrees. So x is equal 45 degrees. Whereas this works out a little more complicated. It works out as x is 26.6 degrees. So that's that makes sense in our drawing, because the half should be first and then the 1 would be next. And that's it for question 4. Let me know if I made a mistake in this, because this is too short and too easy for 6 marks. I don't know if I've messed up something here. I can't see where I've messed up. Maybe a few things that would worry me is around 90 degrees. We're dividing by infinity is fine. Around 0 and 180, we're dividing by 0. I guess that's a problem, but it would still be a problem with cotan. So it must be a case that x is not, they told us x was greater than or equal to 0 and less than or equal to 180. I don't see how it could be, because we're dividing by 0 at those points. But so maybe I'll make a mistake here. 6 marks. I think you'd get full marks for this. Hopefully, maybe they'll take a mark away from me, something I did. Hopefully you'll let me know in the comments. Okay, thank you for watching and have a great day. I'll see you next time. In question 5, they give us this complex number here, -1 minus 4 multiplied by square root 5 I. And they don't say it as clear cut as most students would like, but what they're asking about here is the square root. They say the square root of this can be represented as in the form of x plus I times y. So to write that down another way, the square root of this can equal x plus yi. Basically solve this. Now the problem here, well, it's not really a problem. There's actually two ways to do this. One way, which I'm not going to do because they don't really want us to do it, and I guess actually I can't really do it either, is to use the Moivre's theorem. That is to change this into cosine and sine, the polar form, and use the Moivre's theorem to get it to the power of a half. We just have to multiply the angles by a half, then it's much easier to do. The problem with doing it that way is the answer we get, at least my calculator, some calculators can, the answer I get on my calculator will be in a decimal place, in a digital form, instead of the exact form. So they want your answer to have like a square root in it. So that's one problem, that's out. Also, they give us a hint. They tell us by first forming a quartic equation. It's okay if you don't know what that means. Quadratic equation, so x squared, x and a number. Quartic equation or cubic equation would be an x to the power 3. Quartic is just x to the power 4. So that's going to appear in this, and it wouldn't appear using the Moivre's theorem. Okay, so this it's not an uncommon question. Square root of a complex number. There's always been two ways to do it. This is one of the ways. Let's jump right into it. How we do it? We just square both sides. That'll get rid of this big square root here first. -1, 4 times square root of 5i. On this side, we get x by x squared. X by y is xy. Y by x is another xy. So we get two of them, 2xy, and they both have an I in it. Then we have y by y, that's y squared. We have I by I, that's I squared, which is also -1. So we get a -1. That's what squaring both sides looks like. The next thing we do is something we do in lots of parts of maths, but it's very common in complex numbers. We equate the like terms on either side. The real numbers on the left equal the real numbers on the right. Let's put it over to the side here. -1 on the left is the only real number, is equal to x squared is a real number, and so is -y squared. That's a real number. So we get this separate equation. Rather than this whole thing, we get this smaller one. But also it's true of the imaginary numbers. So -4 square root 5 is also equal to 2xy. 2xy. You could leave an I on both of these, but they cancel. I on both sides, divide both sides by I, it disappears. So from this, we get this, a simultaneous equation. There's two equations, two unknowns. We can solve this. We have x squared and y squared in one of them. So what we do is we take this term and rearrange it so we get something on its own. What have I got here? I've got x on its own. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. So I'm going to take this second term here. Oh, sorry, first 2 divides both sides. To that side. I'm going to take this x and put it on its own. Basically, I'm going to divide both sides by y. This side becomes -2 square root 5 divided by y. I've got x on its own. I'm going to put this x into this equation. Well, let's just do that right now. -1 says -1 equals x squared. That becomes this squared. So that's minus by minus, a plus. 2 by 2 is a 4. Square root of 5 by square root of 5 is a 5. We take multiply now. Y by y is y squared. And then minus y squared is still there. Minus y squared. I've now got to an equation with just one unknown. y squared. It's the only thing in this that I don't know. It looks very awkward to solve. Let's just play with it until hopefully it looks better. We'll put it up here. If I get rid of this dividing, if I get rid of this here, multiply everyone by this, which is y squared. Hopefully that'll fix that. Minus 1 by y squared is minus y squared. 4 by 5 is 20. Multiply this by y squared, it just cancels. It's gone. That's what we're doing. That's why we did it. Minus y squared by y squared is minus y to the power of 4. And this is what they told us we'd find. We'd find a quartic equation, something to the power of 4. Let's get everyone the same side and put them in descending orders. So we'll put y to the power of 4 first, then y squared next, then y to the power of 0, which is what number is. This is the next little leap. It comes up often in exams. We have a quadratic equation, but it doesn't look like it. So it's a quartic equation, but I can rewrite this as y squared minus y squared minus 20 equals 0. That's actually a quadratic equation with y squared being the variable in it. So let's try and solve that. First, a lot of students can just replace this y squared with some other letter. Can't use x, we have that, we have y. K, p is a common one. Replace y squared with p, we just get p squared minus p minus 20 equals 0. That helps a lot of students. Hopefully you don't need that though. I'll just try and solve this quadratic with y squared. How do we get y to the power of 4? Y squared by y squared. How do we get 20? 20 times 1, 2 times 10, 5 times 4. There are options. Which of those options will get a 1? 2 and 20? No. 2 and 10? No. 1 and 20? No. 5 and 4? That will work. They can get to 1 by 5 minus 4. Or in this case it's minus 1. So that will be 4 minus 5 plus 4 minus 5 will solve this. If you're not able to do these factorizations in your head, that's okay. Use the minus b formula. It'll take you an extra 1 or maybe 2 minutes. You'll get the same answer. And the answer we get out here is y squared is equal minus 4, or y squared is equal 5. It's tempting to throw this answer away straight away, and that is correct. But it's also tempting to say, hang on, square root of a minus number, that's an imaginary number, and we're in complex numbers, so maybe this is an okay answer. Maybe we get 4 answers here, two from this and 2 from that. The problem is at the very start of the question they told us that x and y are real. We already had the imaginary part here. This is a real number and a real number multiplied by I. So we know x and y have to be real. That means y squared cannot be a minus. So that one has to be thrown out. Our 2 answers here are y is equal plus or minus the square root of 5. With the magic of editing, I've cleared off a space here to let us solve for x. We have, I've rubbed out the thing I was going to use. We had x is equal to minus 2 square root of 5 over y. I now know what y is. That means x is equal to minus 2 square root of 5 over plus or minus the square root of 5. Square root of 5's cancel. You could just do this question out twice, but a minus divided by a plus or a minus just would get the opposite. So we'd have a minus or a plus 2. The order there is important. That means when I have a minus 2, here's x and y. When we have x being minus 2, y is plus square root of 5. So that's one of our answers, the x plus y. When x is plus 2, the y is minus square root of 5. So that's our 2 answers there. And that's question 5 completed. If you have any follow-up questions or you see any mistakes I made, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 6, they give us this equation of an absolute value x minus 2, the absolute value of x minus 2 equal to 2 sine x over 2. And they ask us to draw a graph of this, this system here, or 2 graphs that'll show us that this system only has one answer. So how do you do that? I'll do it quite slowly. I will draw I'll draw a few different graphs, and then I'll combine them all into one that you would probably draw in the exam. First of all, I'll draw this one. I'll keep this one quite small. How do we draw the absolute value? What you do is you ignore the absolute value, just x minus 2, or let me write that again, y is equal x minus 2. How do you draw this line? This is the equation of a line. Well, it has a y-intercept of minus 2, let's put that in down there, and it has a slope of 1. That means it goes up at a diagonal like that. Absolute value tells you anything above 0 is fine. Sorry, anything above 0 is fine. Anything below 0 gets changed to a plus. So this minus 2 becomes a plus 2, and we go up like that. That's what an absolute value, that's what the graph of this absolute value looks like. This one I'll do a bit slower because I want to do it multiple times. First, I am going to draw sine, and not 2 sine, let me write it here, y is equal sine x. First I'll draw that. That looks like this, comes down like that. That's fine. This isn't sine x though. Let's draw it again. Let's draw y is equal sine x over 2, or a half multiplied by x. So what does this mean? If I were to put in, what are we in here? We are in radians. So if I was to put pi in this one, here's pi, and here's 2 pi. If I was to put pi into this, I get 0. If I put pi into this, I get pi over 2, which is here, which is 1. So if I put the same numbers below here, pi and 2 pi, at this point, in this one, I actually get a 1 out. If I put 2 pi into this, 2 pi divided by 2 is pi. And that gives me sine of pi is, as you can see up here, 0. And you could check other numbers in between, but what you get is something like this. It's much more stretched out. And this goes up to the value of 1 and down to the value of minus 1. The final thing to change is the easy one. I'll draw one more down here. You get the same shape as this, going, that's 2 pi, I guess this bit here is 4 pi. But the height in this case is 2 and minus 2. That's what this final y is equal 2 sine a half x looks like. So if we put these together, let's draw one last time here. I'll draw the sine again. It looks like this. It goes all the way up to 4 pi. And then it goes into the minus world as well. There's 2 pi. They only want the drawing to have pi. So they only want up to pi. That's all that's important to them. Remember what pi is. I'll rub it out here. It's 3.14, roughly. Let's draw this guy on this drawing. This number here, oh, I never said what this number was. It's a slope of 1, or slope of 1. So every time I move right 1, I go up 1. Minus 2, I need to move right 2 to get to the 0 line. This is 2. Or you could put y equals 0 and solve for x. So 2 would be somewhere, here's 3, 2 would be somewhere around here. That's 2. And we would get a line, this line goes up to 2. This went up to 2 here. So this would look like that. And 4 is somewhere around here. And there's 4, 2, which it hits. It would look something like that. 2 answers. They asked we'd only get 1 answer. I see 2 answers on my drawing. That's because they only wanted between 0 and pi. 0 and there's pi. So the world is only, let's put a block around it. This is the only part of the world. It's okay if you draw the rest. Once you had pi here, or 3.14, and you showed there's only 1 answer in this box. That's the answer to 6 part A. You don't have to do it as slowly as I've done. Most students should be able to just draw this straight away. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Part B asks us to show by calculation that this root is between 1 and 1.5. Let me just quickly draw what we had there previously. Something like that and the point like this. The world stops around here. Something like that. The drawing. So prove that this was at 2. This here's 1 and here's 1.5. Show that the answer is between there. How do we do that? Quite simply, we just put the numbers into this equation. So put 1 in here and we get 1 minus 2. The absolute value of that is equal to sine 1 times a half is a half. 1 minus 2 is minus 1. Absolute value of minus 1 is 1. 1 is equal to sine a half. This side is 1. Put this side into a calculator and we get told that it is 0.9588. So it's not quite 1. 1 doesn't work, but these are the numbers we have. Let's put in 1.5. 1.5 take away 2 is minus 0.5. Absolute value of minus 0.5, 0.5. Put 2 in here, we get 2 sine 2 divided by 2 is 1, so sine of 1. Let me write that in. 2 sine 1, 0.5 is equal, we get 1.36. So that's definitely not the answer. 1.5 is not the answer. 1 is very close to the answer. How does this show? Because they're not going to give me marks for that. Well, they'll give me 1 out of 2 marks for writing that. You need to tell them something along the lines of, when I do this, this side is above this side. This one's above this one. We can see that in the drawing. The straight line, the absolute value is above the trigonometric part of it. This is above that. And this shows us as well. 1 is bigger than that. 1 is here, 0.9 is here. When we next do it, so this is at the 1 point. When we next do it over here at the 1.5 point, we see this is at 0.5 all the way down here, and this is at 1.36 all the way up here. This it'd be good if I had different colors, markers, but this guy, I don't know how he does it. I do from this drawing. He has to get somehow to there, and this guy has to somehow get up there. There's no way for that to happen without them crossing lines. You remember, they can never go backwards on themselves. So they have to cross. There has to be at least one answer. Maybe there's 2 or 5 or 7 answers. That went backwards. But there has to be at least one root between there and there. And from our previous drawing, we know there's only one root. In fact, I clean that up and say, we know it looks like this. And this one, I guess, curves up like that. So we can show by, this calculation shows there's only one root. In part C, they ask us to solve this iterative formula to 2 decimal places, put out 4. Before I do all that, they were quite nice to us that usually they ask us to find this formula. And it was a little difficult here, so they didn't ask it. But I just want to show you quickly anyway. You'd have to rearrange this, but the problem is you get an absolute value. So why don't we get 2 answers? And that's the bit I want to point out. We know we are in the minus world. We know from our drawing, this is the positive world of the absolute value. This is the negative world. I know whatever's in this is going to be minus. So I'll do it down here because I want to rub it back out. The left side of that equation is minus x plus 2 is equal to sine x over 2. Solve this, we get, change the sign of everything actually, we get x, bring the 2 over, it becomes a minus 2, but I change the sign, it becomes a plus 2, this is a minus 2, sine x over 2. I'm sure there's one or two students wondering where this equation, why is there, the signs seem wrong in this equation or in this equation. That's why. We knew we were in the minus world of that. They thought that was a little too difficult for a student to do. Well, another year they could definitely just ask that. So this question could have been 4 or 5 marks if they'd left that bit in. Anyway, we're left with this. How do we do this? Hopefully you know how to do this because it comes up every year. It's a guaranteed 2 or 3 marks, 3 or 4 marks even. Just learn how to do these. How I like to think of it is, I think of x0 as a guess. They've given us the guess here, 1.03. We start with a guess. x1 is the next number, and that's where this comes from. If n is 0, x1 is equal 2 minus 2 sine 1 over 2 x0, which we know is right here. You can put all of that into a calculator, all of this into a calculator with 1.05 here, and we get 1.0149, which is approximately 1.01 to 2 decimal places. So that's what they want us to do. This is the 4 decimal places as they asked, and we're going to stay doing this as many times as it takes until our answer agrees with the previous answer. That's the 2 decimal places at least. And this is an awkward question. I've never seen one this long. We actually have to do this 8 times before we get an answer that agrees with itself. So I've never seen it more than 4 or 5. So this is really awkward. A lot of students probably gave up on this question. But that's what we have to do. We go ahead and get x2. I'm going to need lots of room here if there's 8 of them actually. I should be able to use over here. We put this number back into this equation, and we will get, we'll get 1.0281, which is approximately, I can just do that, 1.03. Doesn't agree with the previous one, so we stay going. We put this number, the best number we have, or in fact if you have it on your calculator, maybe it's we have 10 decimal places. We put that back in here and get the next one. And let me tell you a little shortcut for doing all this as I write this out. 1.0166, which is approximately 1.02, still doesn't agree. A shortcut for doing all this, because you don't want to have to write this equation 8 times, which you will have to do this time. What you can do is you can put this number into your calculator and press equals. That saves in your calculator this is an answer. Then you can put this equation into your calculator, but instead of this number, instead of putting 1.03 here, you put, there's a button on your calculator that has answer, and if you press that in this equation, what your calculator will do is it will remember this equation and the previous answer. Press equals, you'll get this number. But what happens next is your calculator still remembers the equation, but now it remembers this is the answer. So if you press equals again, you'll get this number. Again, press equals again, you'll get this. Press equals again, you get this. You can do this really fast just by pressing equals a few times. So that's what I do, and I get x to the 4. I'll reel some of these off then. 1.0266, it's 1.03, still doesn't agree. Let me skip over, let me fill it down here. x5 is equal 1.0178. They want to see all these, I'm afraid. And rounding that off is 1.02, still doesn't agree. x6, 1.0255, that's 1.03, still doesn't agree. It's bouncing forward and back. If we stay going though, eventually we do get there. 1.0189, 1.02, x8 is 1.0246, which is 1.02 again. Finally, we've converged to this being the right answer, 1.02. Even though we had 1.02 before, I wasn't confident. This has given me the confidence. If you press equals again in your calculator, you'll stay getting 1.02. these numbers will just get closer and closer. So if you've done that shortcut, you can just press equals on your calculator 20 times. Usually you get the perfect answer then, or as good as a calculator can do. In this case, I think I had to press equals maybe, must have been 40 or 50 times. But I finally got to, the best my calculator can do was 1.0219468859. And that's correct. That's correct to that many decimal places. And your just normal calculator can do that if you learn how to use it right. And you will get full marks. You don't have to write this, of course, but just I thought you might be interested. This is the perfect answer, and it is indeed 1.02 to do 2 decimal places. Okay, that's it for question 6. If you have any follow-up questions on this, or you see any mistakes I made, please let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day. In question 7, we're given this trigonometric expression and we're asked to put it in this form. This is quite a common question. In fact, they might go so far to just give you this and ask you to try and solve it. They want you to know to use this, and what we do is we put them equal to each other. This is a common way to basically, if you ever have cosine and a sine and you want to add them together, there's a method we can do this by turning them into cosine. So hopefully you've seen this before. How do we do it? This is cosine of an angle minus another angle. We can expand that out. It's in our formula tables. This side here is the same as or multiplied by, well, let me just check my notes. Yeah, here we go. Cosine the first angle, sine, oh sorry, it's both cosine on this one. Cosine the second angle, minus, no, plus, or multiplied in would be or sine the first angle, sine the second angle. Now that might not look special, but what we've done here is we have a cosine theta on the right and a cosine theta on the left. We have a sine theta on the right and a sine theta on the left. What we can do at this point is have like terms equal, just like we did in a previous, I think the last question in fact. We can say all the numbers in front of sine. That's yeah, let's put it up here. That's 7 on the left, and all the numbers with sine theta on this side is or sine alpha. Similarly with cosine, it's 24 is on the left, and with cosine here we have or cosine alpha. Again, if you've done this question, practiced this question a few times, you should be getting to this point. We do the same thing next. We have 2 equations, 2 unknowns, so there is ways to solve this, and there's 2 different ways to solve this. But if you don't remember what you've studied, you might get a bit stuck here. So what do we do next? I want you to think of ways to destroy things here. And when it comes to sine and alpha, there's 2 things that come to mind, and that's the 2 different ways we're going to do it. Sine divided by cosine gets rid of them, it turns them into tan. And another way is cosine squared plus sine squared. That gets rid of them, turns them into just 1. So that's 2 different ways. Let's do the divide first. Let's divide sine alpha by cosine alpha. Or let's divide the whole right side here by this whole right side. If we're doing that on the right, we better do it on the left. So that's 7 divided by 24. This one divided by this one. So divide the lefts, let's divide the right. Or divided by or, that's 1. That's fine, that's gone. Sine alpha divided by cosine alpha, it's tan alpha. And what I've done there is actually, not so much the alphas I suppose, I destroyed the ors. So we're just left with an alpha. This is an equation with 1 unknown. We can just solve that. Alpha is equal the inverse tan of 7 over 24, and that comes out as 0.2838. And actually I think that's the question. That's part A. They didn't actually ask us to find or, which is a bit strange because we're going to need or for the next part. And 9 times out of 10 when they ask a question like this, they ask for or and alpha. So unless I'm misreading it, they didn't ask for or, you're finished. but let's just find R anyway, because like I said, we do need it for the previous part. How you can find R, there's two ways at this point. You could just take this number and put it back in here, and it will, the 24 divided by cosine of this, if you've used the perfect number in your calculator at least, will give you R. If you haven't, it'll give you something very close to R. But let me show you the main way. If I, instead of these two equations, if I square both of these, so I get 49 is equal R squared sine squared alpha. Haven't changed anything. Square both of these, I get, I don't know what 24 squared is, I'll just leave it as 24 squared. R squared cosine squared alpha. What I can do now is add both these together. Add the lefts, add the rights. I get 49 plus 24 squared on the left, and on the right I'll get R squared plus R squared times sine squared plus R squared times cosine squared. Take the R squared out of both of them. I'm left with sine squared plus cosine squared, and like I said a few moments ago, that's 1. This all equals 1. So we're just left with R squared is equal, I'll just leave it as this because I don't think I wrote down the numbers in my calculator. That means R is equal square root of this. And if you put that into your calculator, you'll just get 25. So the problem with doing this way, your calculator might have told you the answer was, I don't know, 24.98 or something like that. And the examiner would take a mark away, but they wouldn't, the rest of the question, they wouldn't penalise you more. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Okay, in part B, they ask us to solve this equation. They say hence solve this equation. Hopefully, I'm really hoping you all notice that this looks very similar to up here. It's identical if you just replace theta with x over 3. That means this side, which we now know is 25, cosine theta, replace theta with x over 3 minus, and what was the number we had there? 0.2838. I hate using this rounded off number. I like keeping the perfect number in my calculator, but we're going to use this so much that it certainly wasn't worth it. An extra note on how we got 25. I do think the exam messed up by not asking you to get 25, but I would point out it's very common to get, and if you just square, it could be got just by 7 squared plus 24 squared, the square root of it. That's where this comes from. So I think maybe the examiner just expected you to know that, to be able to jump straight to that. I don't like it. I don't like what they've done there. But anyway, so instead of solving this horrible equation, we now solve this one here. Let's put a block around it. This times that. It has one unknown. It has x. It's nothing too complicated, in fact. They ask us to give the answers, all the answers between 0 and pi. They don't say it like that. They don't say between 0, all the answers between 0 and pi, because that'd be giving you too much of a clue. But this question comes up all the time. Let me skip ahead even. I usually say this at the end. We're going to end up solving a cosine here. So cosine looks something like this. Cosine has millions of answers. Like, let's say when cosine equals, I know the answers are positive up here, but I'll just pick negative. Minus a half. Minus a half. There's an answer, there's an answer, there's one, there's one, there's one. There's millions of these answers. And what we often get in these questions is we want lots of them. In fact, sometimes we want weird ones. Calculator would just give me this one here. But sometimes maybe we want this one and this one. Or maybe we want the two minus ones. So we have to be really careful, especially when lots of work is going on inside the cosine. Like the answer is going to get multiplied by 3 and we're going to have to add this to it. So it's going to mess it up. What you can do is try and draw this now. And that's not as bad as it sounds. We're going to end up multiplying everything by 3. So, well, let me just sketch it out. It's not necessarily how I do it, but instead of cosine like this, going up to, sorry, there's 2 pi here. This is a cosine x. Cosine of x over 3 would just look like, so if you put in pi here, we would actually get pi over 3, which is this one. So here's pi. If I put pi and 2 pi down here, if I put 2 pi in, I actually just get 2 pi divided by 3, which is somewhere like around here. It's not till 6 pi that I would get 2 pi. So I'd have to continue this on, put in 3, actually I need this much longer. I'll rub this back out in a minute. 4 here, 5, and then 6 here. This would actually look like something like, this should be the very bottom here at 3 pi. And where does it come up? Sorry, no, it doesn't go up through there. Sorry, no, it goes down through there, okay, and up through here. Something like that, really elongated this becomes. And then taking this away from it is like adding, it's like moving everything over here to the right. So let me just do this on one picture. I'll move that over there. And we'll be down there. Multiplying by 25 just gets a 25 up here. So when is this equal to 24.5? Well, that'd be here. There's one answer, there's another answer, and the only answers we want is between 0 and pi. There's pi, so this will be the only 2 answers, this one and this one. Or maybe this one isn't even in it. I'd have to draw it better. So you could do this at the very start to help you out. So really, the one answer I'm definitely looking for is actually this one here, the minus answer from the original cosine, and maybe the second one, because I moved everything to the right. Okay, I'm sorry, that was a bit of an aside, because you don't have to do this, you don't have to think of it this way at the start. I'm going to go through the question from here and show you more of a simple way you can do it. I'm going to show you just to get like 6 different answers, and stay going through the question, and then you'll see which are right, which are between 0 and 3.14, which is pi. So let me rub this off, but this is another way to do it. We can, when we get the answer for cosine, we know the answer we're looking for is the one the calculator gives us and minus the one the calculator gives us. But I'll forget we know that as we go through the question and see how it comes out. Okay, I apologise if I lost anyone with that waffle. Let me start over a little bit. We're just going to solve this equation. Let's rearrange some things. We'd get 24.5 divided by 25 is equal to cosine x over 3 minus 0.2838. Take the inverse cosine of both sides. We'd get the inverse cosine of 24.5 over 25 is equal x over 3 minus 0.2838. We can stay solving this. I've made just a little mistake at this point. If I continue here, I've made a mistake, so I won't. But you could continue solving. You add this to both sides. This will give you, your calculator will give you an answer here. Add this to both sides, multiply by 3. Some students think they're finished, and you'd actually get one of the right answers here. But we're looking for 2 answers. What I want you to remember in questions like this is when you get your calculator to do this work, your calculator is stupid. Your calculator will only give you one answer when there's actually millions. So what you've asked your calculator to do, I'll draw one last picture, I promise. What you've asked your calculator to do here is to, this number, 24.5 divided by 25 is about like 0.9 something. It's all the way up here. You've asked your calculator to find this point here, and it will answer. It will give you out this answer. Yeah, so this here will give you, let me write them all down here. It'll give you 0.2. I think it's 0.2000 something. Definitely rounds off to 0.2. That's this. That's 0.2 in radians. But I want you to remember your calculator is stupid. There's actually more answers. There's lots more. There's, for example, 0.2 is an answer, sure, but so is minus 0.2. Just as good an answer. It's just as possible of an answer. This here is 2 pi, or like 6.48 or something like that. So if this is 0.2, what's 0.2 away from there? I've jotted some of these down. They might not be perfect, the numbers. I was just going rough numbers for the moment. This number here will be about 6.28 minus 0.2. So, oh, that is what I have, 6.08, something like that. And there'll also be a minus 6.08. There's infinite ones. I'll just do one more. Yeah, I'll do 6.48. That would be this one here. 0.2 after 2 pi. There's all these answers and more is the answer to this part. So whenever you get the inverse cosine or the inverse sine, I want you to maybe write them all down or at least think about it, okay? So we're going to think about it at this point. So we are then going to add this to this side, 0.838 to this side, which means we're going to add it to all of these. And all of these will equal, have I done that? Yeah, I think I've done that somewhere. Yeah, I think I've just done it roughly. Adding this number to all of these, we get, I guess I can do this in my head, 0.08, again, just roughly, 0.48, 6.36, 6.4, 6.6, 6.7, 6, I guess, minus a 5. No, I'm still not seeing where. I definitely wrote this somewhere. Minus 5.8, I guess. Roughly, this would be the answer if I add this to both sides. Next, I need to multiply them all by 3, and that would give me the final answer. X is equal to all of these multiplied by 3. So roughly, not the exact answer yet, sorry, minus 15 plus 2.8 minus 17.4. This is one of the answers. We'll have to do this one again a bit neater. This would be about 0.24. That looks fine as an answer. This one multiplied by 3, about 1.32. This one multiplied by 3, that's way outside the range. 18, about 19. This one times 3 is about 20, something like that. The only answers I'm interested are between 0 and pi. 0 and 3.14. This one's out. This one's out. This one's out. These are the only two answers. I knew that from my drawing earlier. You'll lose marks for this because I wasn't too neat. Go back here and let's add these properly. We will get this plus this number. That's sorry, this plus this multiplied by 3. And I think I've wrote down the actual good answers here. Ah, here they are. So it's not 2.4, it's actually 0.251. 3 decimal places, three significant figures they always want. And this, oh wow, that was miles off. This is actually 1.45. So that is 0.2 plus 0.2838, then multiplied by 3 gets 1.45. Again, that's 3 significant figures. That's why this is 2 decimal places and this is 3 decimal places. I think they will take a mark away if you only put 2 decimal places here. If you put 3 here, you're fine. I'm tempted to tell students just always put 7 decimal places because they don't take marks away for being extra right, but they do take marks away for not putting enough down. Anyway, that I believe is the correct answer here. I hope you followed what I was doing there. I just don't really have room to do this question out 6 times and then throw some of the answers away. You do have to think a bit logically at this point that, oh, I'm going to add this number to it and I'm going to multiply by 3. So any minus that's more than this away is gone. So I can discount all of them. This minus though, that's snuck in. A lot of students are going to miss this one. Can't throw that away yet because we're going to add this number onto it. So it's no longer a minus. It's a small number multiplied by 3, which will get us right in the range we want. This guy's small enough as well. After we multiply it by 3, or add this and multiply by 3, it's still okay. This is way too big. I could throw this away already. So when I did this, I could probably already have gone, these are the only 2 possible answers. And it did work out that they were the 2 answers. Okay, I hope I explained that somewhat okay. I'm not happy with that question, but I don't have time to redo it, so I'm not going to redo it. I'm going to let you guys ask me questions in the comments. Do you want me to explain something better? Did I make any mistakes? Things like that. Let me know in the comments. Okay, thank you for watching and have a great day. In question 8, we have a differential equation we're asked to solve. Now, the first thing we tend to do in this question, it's often dy dx. In this case, it's dx d theta. That doesn't really make much of a difference for us. We often have this, we will have this differential in the question if it's a differential equation, dx d theta. What we want to do is we want to separate them out and get them each on their own side. What I mean is on the top row as well. So we leave dx where it is, and we're going to want to put d theta at this side. So multiply both sides by d theta. This disappears, reappears over here. And we want to, with this dx, we want all the x's with it. In all of this, the only x is from this term here. So we want to move this over the left side. That means dividing both sides. So 1 over 4x plus 3. And then we want all the thetas on the right side. Cosine theta is already here. We don't do anything to that. This term though, we divide both sides by this, and we'll get sine over 2 theta. Okay, I think you'll probably get a mark for doing this. Next up, we need to integrate both sides. That's how we solve differential equations. So I won't bother putting it now. Basically, we can just add and integrate to both sides and do it. It shouldn't have too much problem with the left side. We'll go through it in a few minutes. It's the right side that's the difficulty. I don't blame any student for looking at this and going, well, sine, cosine, they go together. They become tangent. They become 1 over tangent, unfortunately. And that's, we can integrate tangent, but it's much harder to integrate 1 divided by tangent. And more than that, it's 1 divided by tangent of 2 theta. Too difficult. So that's not the path you should go down. There's a substitution here. Sorry, let me put in this integration. So let's split this into 2 questions. I'm just going to do this one first. The integral of cosine 2 theta over sine 2 theta d theta. And oh yeah, we don't have any limits for this. Okay, how do you do this? There is a substitution that works nicely here. What you want to look out for substitutions, usually it's the bottom row we're going to substitute. So it's something that when we differentiate it, it will divide into the rest of the question and destroy it or make it simpler in some way. The good news is here, the derivative of cosine is sine and the derivative of sine is cosine. For giving a plus or minus here, which I think the cosine would be, turns into the minus sign. So they both seem very promising. It couldn't be the top row. If we change cosine, we'd get a sine, but then we'd end up dividing everything by it. So we just have 2 signs on the bottom row. So the answer here is, the substitution we're going to find is the bottom row. U is equal to sine 2 theta. We're going to use that. And what I tend to do at this point is just try. If you think it through a little in your head, you plan ahead a little bit of a path, but then just try it. If you go wrong, don't worry. In the exam, your exam paper should be full of, imagine this is your exam paper, an attempt here, an attempt. It should be full of things like this. Just a couple of lines through it. You don't want to make it unreadable to the examiner, but a couple of lines through it. You should have loads of mistakes in your exams. Okay, this is not going to be one. This works out. U is equal to sine 2 theta. So the derivative of u is equal to, the derivative of sine is plus cosine. We'll assume this is something simple, this 2 theta, we'll assume it's just theta. And we'll fix that assumption with the chain rule. So we end up going to have to multiply by the derivative of this, this thing we simplified here. So we multiply this all by 2. We'll put it in out front there. And that means if we rearrange this, that's a theta, not a t. If we rearrange this, we would get d theta is equal to 1 over 2 cosine 2 theta times du. So if I try to replace this original thing we had here, this we'll call it I1, because I'm going to have a few more i's there. This I1 here, this integral 1, it's equal to the integral of cosine 2 theta. But this bottom row, I've replaced that now with u. This d theta, I found out by doing this, that's what this bit does. It finds out that I can replace d theta with this. So I'll do that, 2 over cosine 2 theta du. This cancels with that, and we're left with a 1 over 2, that can come all the way up front, and the integral of 1 over u, d theta. And we can do that quite easily. It's a half natural log u. But remember, we know what u is, so let's squeeze it in down here. We know that's a half natural log. What do we replace? Oh, this guy here, sine 2 theta. It's okay as well if you can do this in your head. A lot of students are just quite good at this and go, well, I'm going to substitute this. It'll cancel in this 2 here, the derivative here, will end up dividing everything. I'll remember that. I'll be left with 1 divided by u, and that's natural log. I'll be left with 1 divided by sine, so it's natural log that with the 1 over. It's okay to do it in your head. This is the slow, methodical way to do it. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Now let's do the other integral we left off. Make a bit of room here. The integral of 1 over 4x plus 3 dx. Again, lots of students can do this in their head. That's fine. I'll do it slow again. I'll also use a substitution. U is equal to 4x plus 3. In this case, we're not trying to cancel anything. We're just going to substitute it out because it's too difficult to do on its own. Again, though, a lot of students can just look at it and go, well, it's going to be the natural log. Sort of like a chain rule, simplifying it in your head, knowing we're going to differentiate this and then divide by it. Anyway, let's do it slowly. U is equal to this, du dx is equal to 4. That means rearranging it, dx is equal to 1 over 4 du. Writing this out again, we get the integral of 1 over u, 1 over 4 du. That's the 4 can come out front. And that's just natural log again, 1 over 4 natural log u, which is equal to 1 over 4 natural log of 4x plus 3. Now I've left out a mistake in both of these, which I'm going to fix when I put them all back together. Really, this guy, where's the final answer down here? This guy should have a plus a c. So should this one here, plus c. And yeah, let me keep all the constants going, as we'll call this C1, C2, and I'll clear off the board here, and I'm going to combine these two answers. I'm going to have this is equal to this. So I'll rub everything out except for this, and we'll put these two answers in below it and continue on from there. Okay, here it is all combined again. These constants, let me just talk about them for a moment. And they're very important to remember. They're not important to number like I've done. For example, let's take C2 away from both sides. C2. A constant taking away another constant. Well, that's just another constant, a whole new constant. I'll call it C3 here, but it's okay just keep calling them all C. You'd have to be a little careful though, you'd have to be careful because they're not all the same number, and that's why I'll just put in different numbers each time. But it's okay for you to get away with it once you don't mess it up right at the end. Now we're nearly finished. We're going to get a lot of the marks for this. We've done the hard work, the integration. You still want to obtain an expression for x in terms of theta. We want to rearrange this so we have x on its own, x equals, and the only thing unknown on the other side is we want to be theta. So let's start doing that, and let's multiply both sides by 4. Yeah, let's be cheeky and just do it like that. 4 divided by 2 just becomes 2. Oh, if I'm multiplying both sides by 4, this becomes 4 times C3. I better be Again, you're not going to lose any marks for just leaving a C there, because it's just a whole new C. Okay, get rid of the natural log. We take the exponential of both sides. So at this side, just get 4x plus 3. E to the power of natural log of something just becomes that something. At this side, let's see, it comes in 2 natural log sine 2 theta plus, well, let's call this C4, a whole new constant. Right, what do we do here? This E and this natural log, can they cancel? Not quite at the moment, it's a little too far away from each other, but we can, well, let me save a bit right here. Remember the rules for natural log. 2 multiplied, or anything multiplied by a natural log, that can just reappear up here. Instead of the 2 there, it's the same as the 2 there. And now just this C4 is a problem. If we rewrite this as E natural log sine squared 2 theta, again this 2 can be wrote in here as well, that's just trigonometry, we get away with that. E to the power of C4, well that's just the same as being multiplied by E to the power of C4. Or again, this is now constant. E to the power of C4 is just a whole new constant. Could call it C5, which is fine. Could call it just C. But the thing, we actually tend to call it A when it's multiplying an exponential like this. So this is just still just a constant, we don't know. And this E and this natural log destroy each other. So let's write that. 4x plus 3 is equal to A times sine squared 2 theta. We're pretty much done. Rearrange this. We get, yeah, let's do it all in one go. We get x is equal, let's see, we have A sine squared 2 theta minus 3 all divided by 4. So that's A over 4 and 3 over 4. Again, let's replace, let's call that A1. And we'll replace this with now A2. Again, you don't have to do it like this. You can just have this constant continue from the start, or you can just keep calling it C if you want. And this is pretty much done, except the only problem with this, you're going to lose 1 mark for this. They don't want the constant. They want to know what number that is. What number should be where I have A2? Yours might look a little different at this point. And we get that because they gave us enough information. They told us at some point x is equal 0. And at the same point, theta is equal pi over 12. So A doesn't change, a constant. That's what it means. It doesn't change. So we can just put these numbers into this. Instead of x, we put 0. A2 says there, sine squared. Instead of 2 theta, we have 2 times pi over 12. That becomes pi over 6. And then take away 3 over 4. Pi over 6, that's, well, that's how I remember anyway. That's 30 degrees. Sine of 30 is a half. So put this in your calculator. Sine pi over 6, you'll find it's 0.5 or a half. A square of that is 1 over 4. So 0 is equal to A2 times 1 over 4 minus 3 over 4. We can already see A2 must be 3. But let's do it slowly. 3 over 4 is equal A2 over 4. Multiply both sides by 4. We get that. 4's cancel. A2 is equal 3. I think you would still lose a mark, or maybe half a mark if they do them. At this point, even though you've done all the work, they just want you to write this again. This line up here one last time. X is equal, instead of A2 though, they want to see the 3. They want to see the number 3. Sine squared 2 theta minus 3 over 4. That's your final answer. If you got a constant at a different point, that's perfectly okay. Once you got to the same last answer, we all should be getting to the same last answer, or something's gone wrong. Yeah, that's it for this question. If you have any follow-up questions about this, anything I did there, ask me whatever you want. I'll do my best to get back to you. Give me some help though by telling me where in the question you're talking about. Okay, thanks for watching and have a great day. In question 9, they've given us 3 vectors in column form here, OA, OB and OC. I've just wrote it as A, B, C. It's quite common to leave out the O part, the origin part, when you're writing these. Just just take a little faster. So if you ever see a vector without the O, it just means it must start at the O. In this question, we're going to see, right up here, we're going to see AB very shortly. We wouldn't write that as just B because there's an A in front of it. Okay, let's see. They ask us to find the vector equation of the line through AB. Let me explain that quickly. A, B, let's put in A and B. So the vector equation for the line, sorry, I should say. For the line, and we put in O here. So what that is, it's a set of instructions, it's a set of directions to get from the origin, 0 here or O here, to any point along this line that goes through AB. How you do that is, and they can look different, we can get very different answers here, by the way. At least two very different answers. We start at 0 and we just need to get to the line. So you can go from OA or you can go OB, whichever you want. I will choose to, so we'll write this line as OR. I'll choose to go from O to A. That's a 1 minus 4, 2. That's a set of instructions that'll get you to A. This will. Next, we want to go a certain number, any number, every number, in the direction of AB. So we write lambda, that's just any letter you want. You can put anything there, A, B, C, whatever, any letter you want. But we need in here a vector that's along this line. So the obvious one would be A to B. But you could also use B to A. I've started off with A to B here. So we need that vector, we need AB. How we get that, vectors don't care how you get somewhere. So they just want to get from A to B. So this should be the same as A to O. Plus O to B. So start at A, go to O, go to B. You've got from A to B. So this works fine. AO is the same as OA, which is the same as, AO is the same as minus OA, which this is the same as just minus A and plus B, or as I'm sure you probably see it, it's just B minus A. Or in this case, B minus A. Minus 2 minus 1 is minus 3. 1 minus 4 is, 1 minus minus 4 is 5. 3 minus 2 is 1. So we can use that vector here. This is your answer. This tells you how to get anywhere on this line. If you want to get to A, for example, you just need to tell me that theta is 0. So I will go to A and I'll go nowhere else. I'll go to A and nowhere else. If you want to get to B, you need to tell me lambda is 1. Sorry, I said theta a moment ago, so that's lambda is 1. If you want to get to B, you go O to A and 1 AB will get you there. If you want to get into the middle, you put a half. O to A and a half up. You want to get down to here, you can put a minus number in. Say minus 1. You go to here and minus AB. Get you down there. It gets you anywhere on the line, this equation. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Right, part B, they want you to find the exact value of the cosine of BAC. Let's add C into our picture here and put it in over here. So they're talking about BAC. So that means we start at B, go to A, and go to C. This angle in here is the angle we're talking about. This is the theta we're talking about. Now they don't want to actually find the angle. That'll trip up some students right at the end. They want cosine of the angle. But you should be thinking, how do I get angles? How do I get cosine of angles? There's a formula. They tell us, they tell you here. It's the scalar product or the dot product. And that's the dot product of two vectors will tell you the angle between them. Now it's important we get the vector going from here though, away from sort of the middle bit. So in this case we're going to, let's put it down here. We're going to get the dot product of AB dot AC. The dot product between AB and AC. Now that's important we don't do AB and CA. A lot of students mess that up. AB and CA would be going the other way. That would actually be this angle here you'd get, which is related. If we get 30 degrees, that would be 150 degrees. They're related, but it's not what we're looking for. So remember, you have to start in the center here, AB, AC. So the dot product of this is going to equal the length of AB multiplied by the length of AC times cosine of this angle we're looking for. So there, BAC, yeah. So that's how we get cosine. Let's just rearrange this. We would get a cosine of, well, instead of theta, let me write it as they have BAC is equal to the dot product divided by the length of AB and the length of AC. So really, we just need to do these three questions. I'll do them all separately here. We'll find AB dot AC first. That's that's not what I have to do first. I have AB, that's fine. I don't have AC, so that's the first thing I'll need to do. I need to find out what is AC. Actually, let's do that up in a little box here, because I think I'll just about fit all this. AC is equal to C minus A, just like what we said here. And that's equal to C, take away A. 2 take away 1 is 1. 3 minus 4, that's 7. 5 minus 2 is 3. So that's AC. So let's do these three things we're going to need. We're going to need dot product. AB dot AC. That's an easy one to do. That's it. Here's AB, here's AC, or yeah, AC. It's just the x's by the x's, or the i's by the i's. 1 times minus 3 is minus 3. Plus 7 times 5, 35. Plus 3 times 1 is 3. 3 minus 3 is 0. This is all equal to, sorry, 35 that is. Doesn't look like a 35. And next we need the length of AB. The length of AB, that's easy enough to do as well. It's you could draw out the whole picture and prove to yourself why it is. And we need a three-dimensional object and all. But it's just the length. It's Pythagoras theorem at this diagonal, and then it's Pythagoras theorem across the other diagonal. Long story short, I'm sure your teacher went through why it is. You probably didn't care because you don't really need to. It's just all of this squared and added together. It's just minus 3 squared plus 5 squared plus 1 squared and the square root of all of that. That's all the length of AB is. This all comes out as 9, well let me write here, 9 plus 25 plus 1, that's equal, sorry, square root of all that, square root of 35. Next we'll do AC. Can do that a little faster, this one here. That's 1 squared plus 7 squared, which is 49. Plus 3 squared, which is another 9. Square root of all that. That's 10 plus 49. That's square root of 59. Okay, that's everything we're going to need to do this. Let me clean the whole board. I'll write this equation one more time and we'll fill in these three numbers. But we're just going to fill these three numbers in to this and we're pretty much done. Okay, just filling in the numbers we found. The dot product we found is 35. The length of AB was, I might have mixed these up, but one of them was the square root of 35 and the other one was the square root of 59. That's it. That's pretty much your full marks. That's an exact answer. You probably could divide these. 35 does divide quite evenly with the square root of 35. That goes in as a square root of 35. Just these two here, and we're left with the square root of 59 there. Or again, you could save yourself one of the square roots by just going 35 over 59. These don't, check on your calculator, but they don't divide in evenly. That's your final answer for part B. Now in part C, they ask us to find the area of a triangle. I'll draw this ABC again. There's three ways to do this answer. One of them is wrong. I'm going to show you that one first. You might get away with getting marks for it. It's easy and short, but it's sort of wrong. They want the exact area, and that's important. The angle we just found was BAC. That's this angle here. So we're going to use that fact because we know the area of a triangle. It's right here. The area of a triangle is confusing having an A there. So let's write actual area. The area of a triangle is equal to half the two lengths around an angle. So the length of AB, which we just found out, times the length of AC, again we just found out, times sine of, in this case, BAC. Problem is we didn't find out sine BAC. We found out cosine BAC. So here's the really quick and easy way you can do this question that I don't think will get you full marks. Just put all in the calculator. A half square root 35 square root 59 sine of the inverse cosine of the square root of 35 over 49. If you put all that into a calculator, you'll get, yeah, let me write down what you'll get. This is where the examiner would know you're full of crap. And you get this number. That's perfectly correct. It's not the exact answer. They want more decimal places. There's a little cheat though. If you only use if you're desperate, because again you might not get marks by doing this. You can guess the answer probably has a square root in it. When they say exact form, especially when we have all these square roots already, it's probably a square root of something you're looking for, and you know this is the answer roughly. Oh, by the way, some calculators will give you this perfect, I'm sure, nowadays. But if you know there's going to be square root, just square this. If you square this, you'll find 210. So this guy is actually square root of 210. That's the exact answer. And I think they'd have to give you full marks if you got that. But that's not how they want you to do it. So let me do it one more way. I'll describe another way, but I'll actually do it one of the ways. Right, the way I would actually do this. They told you we found out cosine is equal, let's just write cosine theta, is equal to 35, square root of 35 over square root of 59. I can make a triangle, make a whole, not quite this triangle, although it's very related. I'm going to make a right angle triangle that has theta here. Because I know cosine of theta is equal to this triangle must exist where the adjacent divided by the hypotenuse is this. That means the adjacent length is square root of 35 and the hypotenuse length is square root of 59. If we could just find this length here, I'd have sine. Sine is equal to this divided by square root of 59. And that's just Pythagoras theorem. That's just this squared, which is 59, is equal to this squared, 35, plus whatever this squared is. I'll call it x squared. X. Rearrange this, we'll get x squared is equal to, what is that? That's 24. So x is equal to square root of 24. This here is the square root of 24. So sine theta, which I want to be able to do this question, sine theta is equal to square root of 24 over square root of 59. So let me write this formula again. The area, I'll just write A, is equal to a half the square root of 35, the length, times the square root of 59, another length, times sine of theta, which is just square root of 24 over square root of 59. Square root of 59's cancel. Multiply 35 by 24, we get 840. So a half times the square root of 840. Don't mess up here, don't write in 420. You can't, a half and a square root can't interact like that. Turn the half into a square root. That's the square root of 1 over 4 times 840. Now they can multiply, square root of 840. Now they can multiply 840 divided by 4 is 210. And that's your final answer again. Sorry, one other way. I'm not going to do it, so I'll just squeeze in the formula I'm going to talk about here. Another way to do it, you needed to get from cosine. Where do we have cosine? This was the cosine. You need to get from cosine to sine. Well, we have a formula where cosine squared plus sine squared is equal to 1. So you could have wrote, let's see, this squared is this squared. So 35 over 59. Let's bring this over to equal. So this comes a minus, and there's a 1. 1 minus that is equal to sine, or sine squared. So let's get the square root of all that. So you could have put that in. It would have just been a lot messier than that. you could have put this in for sine theta into this formula here, a half square root of 39 square root of 59 multiplied by the square root of this. Do a bit of algebra, multiply them in. The square roots can multiply into square roots, fine. 59 would cancel, everything would cancel down, and we'd be left with something similar. We would get square root of 210. Okay, I ended up doing all three, I guess, there. That's all the answers to part C. That's all the answers to question 9. If you have any follow-up questions or you see any mistakes I made, let me know in the comments, please. I'll do my best to get back to you. Thanks for watching. Have a great day. In question 10, they ask us to find the quotient and the remainder when x squared is divided by 1 plus 4x squared. So let's write that down. X squared is divided by 1 plus 4x squared. There's two ways I can do this question. I'll do both of them because they're quite short. The first one I think is probably the shorter one, but it's probably the harder to think through. We need to recognize that when you divide something by something, it goes in a certain number of times. That could be 0 times, could be 1 time, could be 8 times, it could be a half times. So we'll just call that some number here. We'll call it, I'll just call it A. Any letter you want. This is going to be the quotient though. So I guess you know what, let's call it Q, because it's going to be the quotient. Then it's also going to have a remainder. Maybe maybe the remainder is 0, or maybe the remainder is 8 or whatever. It's going to have some remainder, and we write that as the remainder divided by this. Whenever I have trouble sort of remembering how this looks, I just think of a simple example like 8 divided by 3. 3 goes into 8 2 times plus 2 remainder, and that's 2 divided by 3 would make this make sense. 2 plus 2/3 is 8 over 3. Just like here, it goes in a certain number of times plus a remainder, and we write the remainder divided by that to make the equation work. We can just solve this. Multiply everybody by 1 plus 4x squared. We're going to equate like terms. Multiply everyone by that. The left side just becomes x squared. Q is the only one that gets multiplied. We get well, let's do them by out. Q times 1 is just Q. Q times this is 4q x squared, and this just becomes r. Like terms, just equate like terms. X squareds must equal the x squares. So that means the 1 in front of this must equal the 4q in front of that. Or rearrange that, it must mean q is equal 1 over 4. That's the quotient. That's how many times this goes into this. 1/4 times. The second way I'm going to do it will show you that a bit more clearly as well. What's the remainder? Well, just equate the terms again even. There's 0 number terms on the left. There's q here, which is 1 over 4 now, plus r. So r must rearrange it, move that over, we just get r is equal minus 1 over 4. There are your two answers. You didn't have to write it out like this. Just have to do this little sum. Q is 1 over 4, or the quotient is 1 over 4, and the remainder is minus 1 over 4. Another way you could do that, my personal favourite, because I love doing long division, although this isn't really that much of one. We've got x squared and we're going to divide into it. I'll rewrite this though as instead of 1 plus 4x squared, I'm going to write it as 4x squared plus 0x's plus 1. And instead of x squared, I'm going to write that as plus 0x plus 0. Whenever I do long division, it's really good to write them out, first of all in the correct order, the same order as each other at least, and with all the missing terms put in as a 0. So how many times does this divide into this? Well, we just look at the first terms. What would you have to multiply this by to get this number? You'd have to multiply this by 1 over 4, and that's where we get the 1 over 4. So you could do it as simply as that. You could do that in your head, in fact, get the quotient. And then we just multiply 1 over 4 by all of this. This becomes x squared. 1 over 4 by that becomes 0 x's. 1 over 4 by 1 becomes 1 over 4. Take it away and we find our remainder. No remainder there, no remainder there. 0, take away this, it's minus 1 over 4. There's your remainder. So again, it was quite easy and straightforward both ways. I guess there's only 2 marks for that. Still, I think it was a good, clever question, that. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. And next they give us part B, which doesn't look related whatsoever, but a hint that it is. I've left the previous answer from part 1, at least roll a different way, the quarter and the minus quarter. And I say hint there because definitely part A is a hint how to do part B. Maybe you should be racking your brain to think, how are these related? Because this is a hard question to do. I'm going to just give you my thinking on it and hopefully help you in a few different parts where we have to take a leap. Because often maths, especially difficult maths like this, is we can all learn how to do the different parts, but there's multiple parts where you're going to have to take a leap to figure something out. I think this is one of those questions. So what is that leap here? Well, how do we do integration? There's a couple of different ways we can do difficult integration like this. The two main ones that we're going to think on here is substitution and integration by parts. Now in both of them, we end up differentiating part of it. So whatever we substitute, we end up differentiating it. And so differentiation is important. And what should be jumping off in your head a little bit is inverse tangent. So you could get stuck up changing this into sine and cosine and trying to do it that way. It's not going to work. Inverse tangent of something. We have a formula for that. We know how to differentiate that. And importantly, we don't know how to integrate it. So that's a great hint. Maybe we could substitute this out and differentiate it. Let's write the derivative of it over here anyway. It'll be useful to have d dx of the inverse tangent of x is equal to, what's it, 1? Yeah, okay, 1 over 1 plus x squared. We know how to differentiate something that looks a lot like that. And the answer, 1 plus x squared, that's starting to look somewhat similar to what we had at the start. Now, it's okay if you don't put that connection together yet, but still, we know maybe some differentiation here is involved. Let me just think through substitution. Again, it's not going to work, but if we were to substitute this, we would end up getting this as a derivative. And then we would end up dividing by this, which means multiplying by this bottom row. So we would have x multiplied by that. That doesn't get rid of anything. It still leaves us a bunch of x's, and we'd have this new substitution of u. So substitution's out, unfortunately. It looked like a good way, so it's okay if you tried that. Don't feel too bad. It's a good thing to have tried, even if you've gone through a few lines of it. But you will get stuck. It's not the path to take. The path to take here is integration by parts. Let me write the formula for that down here. When we have two things multiplying, a u and v often, or u dv we write. I'll explain why in a moment. We can rearrange that. Think of this as just two things, a u and v. One of those things has a dx on it though, is what we have here. So maybe it's u is x maybe, and v is this whole thing with the dx. That's why we have the dv. Or maybe switch them around. It's maybe that's the u part I'm covering up, and the dv is x dx. Okay, anyway, if we have two things multiplying, we can rearrange it so it's just u times v, and we get the we evaluate that, minus the integral of v du. Basically, you can think of this as, this is too difficult. How about we change it to make this one, and hope, really hope, that this one's easier to do. And it will be in this case. So what I like to do there, I know students have like a list of things to go through for this. All I like to do is I write uv and du dx. You don't have to put the dx in if you can think it through in your head. Dv dx. I like to fill these in. Which is the u and which is the dv dx of the two choices here. So basically, does x go here, or does the inverse tangent go here? They're your two choices, and the other has to go here. So it could be x inverse tangent. Now it's not going to be inverse tangent here because, let me just write it in, the inverse tangent of 2x. Because once you get here, you need to find out what v is. To do that, you need to integrate this. And we can't integrate this. That's the whole point. That's the trouble we're having. So it's not going to be that. So the u is going to, I don't have enough room here, let me clean that up. The u is going to be the inverse tangent of 2x. And that means the v part must be the x. Just the x here. And the reason I write it like this, because I think it's just easier to see, but we can move the dx over. And that's where this combined with this gets this whole line. Okay, it's just, this is more just something to help me think it through, what u and v is. Because we can integrate this. The integral of x is just x squared divided by that 2 there, divided by 2. And we can differentiate this. It's nearly this. It's not quite 1 plus 1 over 1 plus x squared. Because x is 2x now, so it's 1 plus 2x squared. But we had to use the chain rule there. This is cheating. We cheated by putting that 2x in. So we have to fix our cheat by differentiating this and multiplying. So we multiply by 2. And that's this 2 in here. The derivative of this is what we're multiplying by. Now it's still not obvious at all that this is the right path. Often when that's another really difficult thing about this question. Often when you start down the path of integration by parts, we go, oh, this was working. I've got something here. In this case, it's not obvious at all. We're going to end up with this multiplied by this, and we still have to integrate that. Nothing cancels there. We'll have an x squared divided by a 1 plus 4x squared. That doesn't cancel. But that's where the part 1 comes in. This is what we'll end up with. So we can't integrate this, but we can integrate over here. Let's write it out. So this whole thing now becomes true integration by parts. This whole thing becomes, let's name this I. This whole thing I becomes u times v, which is just the inverse tangent of 2x multiplied by x squared over 2, and that's evaluated between 0.5 and 0, minus the integral of v du. So that would be x squared over 2 multiplied by 2 times 1 plus, let's see, 4x squared. And this is still between 0.5 and 0. We're still not done, but we're now looking like this could be a path. The 2's cancel. X squared divided by this. If you were unsure you were on the right path, looking back to part A should convince you, yes, I'm on the right path here. Like, why did they ask that in part 1? What has that got to do with the rest of the question? We now know we're on the right path. Okay, I'm going to clear everything off the board and we'll just start. Actually, you know what? We'll just do this question here and then we'll put this back in to save a little bit of ink. Okay, all of that work got us to this point. The integral of this is the same as this number here minus this integral. So let's try and do this integral here. It's not as bad as it looks. First of all, I'm going to save a bit of room because I don't want to write this every time. I'll cheat a bit. You guys can pause, rewind, so please forgive me for this. This here is identical to this, so let's replace that. This becomes 1 over 4 minus 1 over 4. Well, let's take the 1 over 4 out actually. 1 over 4 comes out here. 1 minus 1 over 1 plus 4x squared dx. This is a lot more manageable than the previous one. So let's try and do this. First of all, two integrals. The first one's not too bad. I'm just going to have to write this loads of times, I guess. X squared over 2 inverse tangent 2x. The integral of 1 is just x. So this becomes minus a quarter x. Then the next integral is minus by minus, so that's a plus. There's still a quarter here. And we have the integral of 1 over 1 plus 4x squared. That's dx here. We've already done a few hard integrals in this question. We're left with another hard one. In fact, this I'd say is maybe the hardest one. A lot of students are probably going to get to this point and get stuck. Because you could try substitution, it's not going to work. You could try integration by parts, it's not going to work. How do we integrate this term here? The answer is actually shockingly easy. I sort of had the answer up on the board previously. We used the answer previous in the question. We already said the derivative of the inverse tangent is 1 divided by 1 plus something squared, or x squared. The opposite is true. If you get from, it's right here, inverse tan, the derivative of the inverse tan goes to 1 over 1 plus x squared. The same is true the other way. If differentiation goes this way, integration goes that way. The integral of this is equal to that. The integral of this is nearly equal to tan, and we had it exactly earlier. If only there was a 2 here. That was the answer when we differentiated the tangent earlier. We got a 2 divided by 1 plus 4x squared. If only there was a 2 here, it would be easy to go backwards. So let's just put 2 there, and we'll fix our little cheat by putting a 2 out here. That means this, let's continue on over here. We'll have x squared, I'll just write the whole thing again. X squared inverse tangent 2x minus 1 over 4x plus 1 over 8 now. And the integral of this just becomes inverse tangent of not x, but 2x, because we get 2x squared down here. And that's where this 2 appeared from as well, of 2x. That's all of this. Let's put a big bracket in here. All of this is evaluated between 0.5 and 0. That's what we're pretty much done. That's the integral of this original mess they gave us. All we have to do is fill in these numbers, and it's not as bad as it looks. 0.5 multiplied by 2 is 1, so the inverse tangent of 1, and that's just pi over 4, or 45 degrees. But we'll stick with radians. That's just because I assume this is radians, because they're going into actual numbers here. So if there were degrees going in, if we wanted degrees out here, we'd also want degrees out here, which means degrees would have to be up here. But anyway, they want radians. I'd say they'd find a way to give you marks if you put in degrees. The inverse tangent of 1 is pi over 4, but also has to go in here. This is a half squared. That's a quarter, and that's a half of a quarter. So that's 1 over 8. That's pi over 4. 1 over 2 multiplied by 1 over 4, that's another 1 over 8. Plus 1 over 8, and this is pi over 4 again. Put 0 in. The inverse tangent of 0 is 0, so you're done. Put 0 in here. 0 multiplied by anything? 0, you're done. Inverse tangent of 0, you're done. Zeros didn't matter, you don't have to take anything away from it. This is our final answer. 1 over 8 and pi over 4, what's that? That's 1 over 32. Another 1 over 32, that's 2 over 32. That's 1 over 16. Pi over 16, I guess. 1 over 16 multiplied by pi, or pi over 16. Take away 1 over 8. That's it. That's our final answer for, I don't even know what question we're on. Question 10. That was easily the hardest question in this paper, I think. It took, in maths, there's often we can just do work. We'll just do work and find the answer. In this question, I think we needed to take leaps. And you often have to take a leap. That separates the people who get 80% from 90 from 100. This question alone, I think, had about 2, probably 3 leaps of knowledge. You had to recognize that the integral of this is tangent. You had to recognize that integration by parts does the question. I guess you had to recognize that the part A helped in part B. It was a hard question. So if you have any follow-up questions for me, please put them in the comments. I'll do my best to answer you. Thanks for watching and have a great day. In question 11, they give us this graph here, which corresponds to the equation y is equal to 5 sine 2x multiplied by cosine of x squared. They want us to find the x coordinate of m. They want to find the x part where m is. How do you do that? The first thing that's probably going to get you a mark is simply by noticing that they want dy dx. Specifically that they want it equal to 0. That might get you a mark. It shows you how to get the first mark of they want to find dy dx. That's what they want you to try and get. So let's try and get it. Here's y. What's dy dx? We have two things multiplying each other. So let me first say you could start breaking out sine 2x now. You have a formula for that. Do I have it there? No, it's not on my screen at the moment. Sine of 2x. I think is that the one that's just sine x cosine x. Anyway, it's a formula we have. We could separate this out, maybe make this easier, maybe make it harder. The first thing I would just try and do is just differentiate what we have here. We have two terms. That's the product rule. They're both multiplying. There's a product rule. Product rule is not too hard to deal with. I take the first term, leave it alone. So let me write that out. 5 sine 2x. I'll leave that alone. And I'll multiply it by the derivative of this one. We're going to need we need a chain rule for that. This is something squared, so we'll just treat it like the derivative of something squared. So multiply by 2 cosine. So that's something squared just became 2 multiplied by that something. But we cheated. That's the chain rule. So we still have to multiply by the derivative of cosine. The derivative of cosine is minus sine. So that's the first half of the product rule. Sorry, I'm probably losing the track here a bit. Two things multiply each other. Left the first alone, differentiate the second, multiply them together. Then plus, leave the second one alone. Cosine squared, leave that alone, multiply by the derivative of the first one. The derivative of this is 5 multiplied by the derivative of sine is cosine, leave the 2x. And then multiply by this 2x, because again we're using the chain rule. This is cheating by just differentiating sine 2x to be cosine 2x. We need to fix it by differentiating this complicated part in here, which is just 2. So multiply that by 2. That's 2 multiplies by the 5 though. Be careful of that. Yeah, I usually I'd leave the 2 up here. Let's put in brackets up there. There we go. Okay, that's your answer. Just put in 0. And that's a lot of your marks right there. You will probably be up, what was it, 6 marks for this first part. You're probably up to 3, maybe 4 marks for getting this. We just now need to solve this. We have an equation. Let's move things around. Clean things up, move them around. Let's see, this will become 5 times 2, that's minus 10. Sine 2x, cosine x, and a sine x. And let's move this over to the other side of the equals. That'll become a minus as well. 2 times 5, that's a 10 as well. And we have, let's see, cosine squared x, cosine 2x. Let's cancel the 2 10s. Divide both sides by minus 10, in fact. And that's that gone. Let's see, we have cosine, lots of cosine. Cosine x here can cancel one of these two. So that's gone there. And we're left with, let's see, sine x and sine 2x, and cosine x and cosine 2x. Again, we could try expanding out these cosines, expanding out this sine 2x, the double angle formula. But we don't need to. If you notice here, divide both sides by this. And we get, let's see, 1 will appear here. This side we will get cosine 2x and cosine x. Look, they divide each other. Sine 2x divided by cosine 2x becomes tangent 2x. Sine divided by cosine, that becomes tan of x, and that equals 1. We're nearly done. We're going to have to use the expand this out, the double angle formula. And that's so this becomes tangent of 2x. That becomes 2 tangent of x divided by 1 minus tan squared of x multiplied by this tan x, and that still equals 1. We have tan by tan on top, that's tan squared. 2 tan squared x over 1 minus tan squared x equals 1. Let's multiply that across. We get 2 tan squared x is equal 1 minus tan squared x. These are the same. Two tan squares take away 1 tan squared. Well, this is take away, becomes added that side. So that becomes 3 tan squared. Tan squared with a 3 out here equals 1. Divide both sides. Square root both sides. We get tan x is equal 1 over 3. What is that again? That's a common one, isn't it? Pi over 6. X is pi over 6. Just be careful, is that your only answer? Remember, there's infinite answers for this. It's pi over 6 or pi plus pi over 6, so that's 7 pi over 6. It would be another answer, and so on and so on. But we know our answer is between 0 and pi over 2. So just to draw a tangent out here, that's like this, and where's there's pi over 2 here, there's 0. So the only answer we'd get is the first one the calculator gives us, is this answer here. So that's it, that's the answer to part A. X is equal to pi over 6. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, they want us to find the area between x equals 0 and x equals pi over 4. We just found out this is pi over 6. So pi over 4, probably somewhere around here. They want to find out the area of in here. I guess they say x is equal pi over, the line x is equal pi over 4, which would be this line here. So between this line and the y-axis and the x-axis and the curve, the only thing enclosed by all 4 of them is this shaded region here. How do you find that? I guess you probably get a mark just by writing how to do it. To do this, we just get the integral of y, or in this case 5 sine 2x cosine squared x dx between the two parts they want. So between 0 and pi over 4. Pi over 4, wasn't it? Yeah. Because what integration does, it goes between a curve and the x-axis and whatever two numbers you put in. Now this would be a difficult question, or how do you start this, where do you begin? But they've helped you out on that, which is sort of nice of them. They've told you how to begin. They told you to use substitution. U is equal to cosine x. Now they do that because it's a difficult question as you get into it. So to substitute this, well, the first thing you do is you differentiate what you're substituting, because you're going to need that in a moment. So du dx, derivative of cosine is minus sine x. So I just rearrange this and we get dx is equal to 1 over or minus 1 over sine x du. So let's put all that into this and see what we get. We know we're going to get the right answer because they told us to do it, but it's not going to look right. So that's why they gave you the hint. They're trying to push you along to that path. Substituting this in, we get 5 will be a 5. Let's see, sine 2x hasn't changed. Cosine squared, that becomes u squared. And dx becomes a minus 1 over sine x and a du here. This is all integrated. The problem is it doesn't seem to have helped. If sine x divided by sine 2x would be sorted. If you did that, you're going to lose marks because it doesn't divide in. Sine 2x doesn't divide by sine x evenly. So what do? What we do is we replace sine 2x. We have a formula for that. They tell us that sine 2x is equal to 2 sine x cosine x. It's our double angle formula. So let's take 5 out first and the minus 1. Let's bring that outside, minus 5. Sine 2x, that becomes 2 sine x cosine x 1 over sine x is still in there. Du. Oh, I've lost a u squared. Let's put the u squared up there. U squared. Okay, this is better. Now sine x does cancel. But we're still left with a cosine x. What did we do with that? This probably tripped up some students. They probably did brilliant up to this point. It's good to notice, to find this thing here. But what do you do with this cosine x? Remember, that's what we're substituting. That's u. Cosine x is u. So we can just put another u here. So let's see, 2 times minus, that becomes minus 10. What's left in here is u by u squared. That's u cubed. And du. That's it. This we can integrate. The answer to this is, let's see, minus 10 times u to the power 4 divided by 4. That's evaluated at some numbers which we don't know. We could figure it out, just put in pi over 4 in here, and we find out what that is. I don't know off the top of my head, 1 over square root of 2 maybe, just I'm remembering the rest of the question. But we don't have to do that. That's how I like to do it. I like to change my units to these u units, but you don't have to. I'll leave them blank, because this is now the same as minus 10. I know what u is. It's cosine to the power of 4 instead of u to the power of 4 over 4. And that's divided by 4, isn't it? Yeah, and this is evaluated between pi over 4 and 0. So let's put them in. Cosine pi over 4, yeah, it was 1 over square root of 2. So this all becomes minus 10 over 4. This becomes 1 over square root of 2 to the power of 4. Take away, we put 0 in. Minus 10 over 4. Cosine of 0 is 1 to the power of 4, or just 1 really. This is our answer. We just have to clean it up. Let's see, 2 square root of 2 squared is 2, and another squared, power of 4. Square root of 2 to the power of 4 is 4. Double checking your calculator if you're not sure. 10 over 16 that becomes. This becomes plus 10 over 4. Or multiply this by 4, that becomes 40 over 16. That becomes 30 over 16. Which isn't the same as my answer, but I see why, because 2 goes into both of these. 15 over 8 is the final answer. And that's it for question 11. I don't think as difficult a question 11, but although there's certainly a lot of tricky parts in it. If you have any questions about it, let me know in the comments. I'll do my best to answer you. Thanks for watching and have a great day.